Right. So starting this week, we're going to look at data structure. We have the following, including this week, 4 weeks, to look at various different kind of data structure with increasing complexity. And then we'll close this particular module with the introduction of various different kind of algorithm that is going to be applied to the most complicated data structure that we have, which is the graph. So the learning outcome for today will be to number one, we're going to introduce the common approach where we are going to use to introduce data structure, which is the abstract data type. And then based on that, we're going to explain really what we mean by having a linear data structure. In total, we'll have stack, queue, and also priority queue that fall into this particular category. And then I think the most important thing, of course, is to see how those different data structures can be used in action. So first, going to talk about the abstract data type. And the important thing over here is to try to separate the abstraction where we focus on the functionality and also the design. And after that, then we will talk about the actual implementation. So based on that, throughout this whole module, we're going to increasingly look at a data structure that with more and more functionality. So the focus for today, which is the linear data structure, is the simplest of all. But later, we are also going to talk about data structure that comes with more complicated relationship. For example, the relationship can be hierarchical, or it can come with any arbitrary linkages. That is the network relationship. And collection of data objects essentially is our major purpose when we have these data structures. So if you look at anything that's around us, essentially they can be viewed as a collection of certain items. You can have a course catalog that is a collection of all the courses with all the detailed information, description, prerequisite, and expectation, so on and so forth. And then you have a car park that's essentially a collection of cars. So mathematics also come with all kinds of collections. You have matrix, which is the two-dimensional information structure that allow you to store numbers with a very clear row and column structure. And then you can have a sequence, for example, the Fibonacci sequence that we talk about, or arithmetic series, or geometric series, so on and so forth. So in computer science, we're going to introduce data structure as a way for us to collect and store all the information that we will find useful. Right. So when we talk about ADT, abstract data type, the major focus over here is that we want to focus on functionality, right? So we want to define what are the operations that will be allowed, but we do not get into the detail about how that particular operation, that functionality is going to be implemented. And there are three different goals in that. Number one goal is that we would like to hide the complexity. So you can see on the right hand side, this is the actual implementation, but it's like it's walled, all the detail are being walled from the actual usage or actual client who is actually using this particular method. So we call this feature encapsulation. We isolate the user from the complexity of the implementation. And then with this particular feature in place, it basically means that because the user of this function doesn't really get to see the implementation. So if let's say you are correcting the functionality, you are making your method more efficient, all of that will be local to the data structure method that you're developing, right? So the user of this function should not be in need to modify the program in any given way, right? So this is what we call the feature of localization. The final feature that again is a direct result of the previous two features is flexibility, right? So now just imagine we have the first implementation, but after a while, we have made some modification to it to make it maybe more efficient. Maybe we can use it differently in different contexts. the user of this particular function doesn't need to be aware of that, right? But he does have the choices. He can use exactly the same code, but just linking this particular user's function to different libraries, different implementations, then the whole program should work as before, right? So these are the nice features that we want to have. So that's the reason why for throughout this whole classes, not just this week, but also for the following few weeks, we're going to try to adopt this particular structure as much as we can. We start from the description of the functionality. After we are aligned, then we begin to think about how we can implement that functionality. We focus on a particular implementation. Right. To conclude this particular session, let's look at a very common data structure that's available in Python. It's called list. Couple requirement. If we have the list, we basically assume that all the items inside the list, they should follow certain order, which means that for each generic item, you should have the successor, right? So you have the next item, and the only exception is that if you are the last item, you will not have any successor. So in terms of operations, again, this is definitely not comprehensive, but just as an example, we can list a couple of operations that we plan to support for this particular abstract data type. For example, we can require that the list to be created by a certain function. We can insert a new item into the list at a specific position. We can get a value of a particular at a particular position. We can remove the item at a particular position, and we can count the numbers of items. And I think, again, if you are already familiar with Python, you will see that all this different operation that we listed over here, you can actually find the corresponding function that we can use in Python. For example, if you like to create a new list, just use the empty pair of a square bracket. This is the creation of the list. We can append a particular item. We can insert a particular item at a designated place. We can read the value. We can delete the value. We can measure the length. Okay, so just to give everybody, I think, an overview about the kind of data type we're going to talk about. For today, we're going to focus on the linear data structure, which consists of two major types. We have stack, we have queues. And then in the class, we're going to spend some time to talk about the usage of hash. In a way, it's also linear, but slightly more advanced. So we're going to probably demonstrate how that can be useful. And then starting from the next lesson, we're going to look at data structure that comes with structures. And first, we have a very organized structure that's a hierarchy in nature. We call it tree. And the final week, we're going to look at where relationship can be pretty much arbitrary. We call it the graph, right? So in terms of roadmap, again, repeating what we have shown earlier, this is our plan for this whole module on the data structure. Right. Finally, in terms of the references, we will rely mostly on the handout that we have prepared in SMU. So you can find this particular set of handouts in the copyrighted material. And then, of course, the hash table, hash map, or in the Python context, we call it dictionary. This is a very useful data type. It's not officially listed inside our handout, inside our course material, but I will do a demonstration in class to show you how hash table, how dictionary can help you make your program more efficient.